Hi everyone, this is Nitish here filling in for Salil today. So Salil is not feeling well. He was about to share with you entry and exit, automated entry and exit, from a trade, from a position. So we will not be doing that. Rather, we'll touch a little bit upon it on the schedule function and the schedule library in Python. But rather, I would just like to revisit what Salil did with you guys last time, which is automated strike selection, right? So while I mean, everyone programs different way. Everyone, no two people will do the same thing the same way. I think we all remember our maths or science classes in school, where no two people. Okay, now okay, so you guys can hear me. So remember school, right? None of us did the same math problem the same way, right? And some of us took a nice little beating from teacher. Why didn't you do it the way we told you? So similarly in programming also, of course, everyone programs differently, and Salil gave you his idea of automated strike selection. Um, so if you guys have been over our the Breeze endpoints, you might have seen that we have an endpoint that almost no one else has, which is the get option chain, right? We have a get option chain function, and I think this is the automated strike selection has a beautiful use case here. The strike. So let's try to today implement using the get option chain to automate strike selection, and also because of the way we will handle things, you will be able to so different people trade different way also, right? Just like programming, so everyone's trading style is different. So in keeping with that, some people would want strike selection based on how many strikes out of the money their contracts are, or in the money their contracts are. So for some people, the strike selection is merely about how many strikes ITM or OTM we are. Right? For some people, strike selection will be more about the risk of the position, the delta of the position. So if you specifically want, one moment please. Yeah. Okay. So yeah, I'm sharing a cabin, so sorry for the thing. So yeah, so automated. So for some people, it may be about choosing the right delta, right? You want to select a strike at which the delta position is 0. For some people, it might be about the IV. How much IV do I want? Do I want in my position, and so on and so forth. So there's as many people, as many trading styles, and as many strike selections. So let's get started today with a strike selection using the entire option chain, right? Using get option chain. So as always, the first step would be to generate a key. So you would want to head over to your API Breeze homepage, log in, generate the .p. Let me do that here. Okay, the .p is. Don't look at my screen. Don't look at my screen. Right. Now we want to head over to view apps. I'm using this. I was writing some code for some Flask-based webhook. So let me just reuse that app for today's demonstration. All right. Oops. What? All right. So I got my session key. All right. So now one of the best practices in Python in writing a strategy is not to keep your credentials in the same file. So what we can do, what I have done rather, is that I keep a separate file called breeze configs, in which I have an object, in which I have a class, and in this class I keep my credentials, right? And when I need to, I import it, right? When I need it, I import it into a file. So here I'm doing that. Yeah. So to import the file, first you'll have to import sys, right? and then in sys, you would do something like, let me just take the short way out. Right, something like this, syspath append, give it the absolute path to where the file is, and then when you call import function after this particular, so here what you've done is that you have told your code, the module you are running, that this path is now a part of the system path. So now when you import, you can when you import, your Python module will look in this particular path, and this may not even be in the same path as your current file is, right? So let's just do import now from. So I had named my thing as Python config, breeze configs. So from breeze configs, import breeze config. I hope that's what it is. Breeze configs. Okay. Now, since it's a class, you'll have to turn that class into an object. So, so let me just say configs is equal to breeze configs. So first, again, what are we doing? First, we're importing system. Then we're saying syspath append. Now we're importing. And from the imported class, we're generating an object. Now this object will have, you can check it out, this object will have the configurations that we have coded there, right? So you look at the last few, the initial ones are just system, methods or classes, and the last three are. So now we are ready to import it. Okay, so we're all set up with our configurations. Now to look at this function which was there already on the screen. Now, one of the things that we will be doing in this, in this we'll be looking for locating particular strikes in a given array of strikes, or in a given list of strikes, or a given list of contracts. What bisect library does, bisect makes it easy for us to sort an array and to quickly come go in and out of an array. So we import bisect here, and then we create a function which will help us. Let me just move this terminal down. Right. So what it will help us do is it will help us locate the exact strike we need. Where will the strike be located? The strike will be located somewhere inside a list of strikes. In a list of strikes, we will locate, where our current spot is. So you'll have, the integral, the multiples of 50 or 100 that are the strikes, and somewhere in there we will locate a floating point spot, and then from that spot, we will count int strikes away. Okay, so this is a habit I have. I mean, you might notice that every variable, I start that variable with the type it is. So in Python, because it's not every, variables are not initialized in types, so it helps me remember what kind of variable it was. So we've got an integral number of strikes away from a floating spot in a list of strikes. This is what this function will do. So if you have any questions, if I need to place an order for more lots, say 100 lots, how can I automate this? So Srinivas, you'll need to write separate helper functions. So one of the things we are trying to do in our GitHub repo for examples, Python examples, we will write some helpful functions. So maybe I'll take this as a request and we'll add a function to the GitHub library for this. So coming back to this, if anyone has any doubts so far, please feel free to put in chat. We can take. We will be having question answer later, so all the miscellaneous questions you'll have will be answered then. So for now, we have So for now, what we have done is we imported our our settings, our configurations. we have created a function to locate a specific strike based on a floating spot. Now we're ready to begin, right? Now we're ready to get our option chains. So we will import from Breeze Connect, import Breeze Connect, right? That's the first thing. Now we're ready to talk to Breeze. Here, let's start communicating with Breeze API. App is equal to Breeze Connect dot wait, what is that? Okay. Okay. Copy this boilerplate code. Right. So now we already have our config stored here. So let me just show you, for example. My API key is already in my other file, right? So we'll just initialize the app. The object is created. We will give it our session token and API secret. Right. And then we will, okay, it's connected, right? So now we can start coding. Now we can say app.get option chain codes, right? So let's say we want to start with Bank Nifty. Let's say stop code is equal to CNX ban. Can you please show how to trail stop loss? Fair enough. If you could specify whether, so there are two types of stop losses, right? One is a stop loss that you send and keep at the exchange, and the other is stop loss which you monitor. You actively monitor your position and you send the order as a normal order as a trailing stop loss. So if you could specify that, maybe you could cover that in one of the sample codes, right? Coming back to this, so we want CNX ban. We want exchange code. We're looking for NFO, right? Why is it doing that? Exchange code NFO, right? Let's start with call, right? Let's get call codes, and expiry date is equal to. Oh wait, we forgot to import date time. So let's import date time. So expiry date is equal to date time dot date time. Okay, date time dot date dot 2023. Let's say we were looking for April monthly expiry, right? Do we have everything we need? Stock code, exchange code, expiry date, product type. We forgot product type. So let's specify our product type is options. All right, I think we have everything covered except for date time, which ideally should be in a particular format. Let's see what format this brings us. For date time. I think %C should do it, right? So string format time, %C. Oh no, this is the question. Sir, I'm trading Nifty short strangles with 25% stop loss. If one leg hits stop loss, bring another leg to execution price. Can I build strategy in Breeze API regarding this? Yes, certainly, Shinu Babu. You can definitely write a strategy. You can definitely write this strategy in Breeze. In fact, if you follow the Salil's webinar series, you will end up doing that, right? So we will end up with a strangle trading strategy, an intraday strangle strategy. The particular stop loss will be up to you. The strategy, whether you want to replace a leg or whether you want to, ship a leg and ride the other one, that's completely up to you. Raghavendra says, so basically I placed an order using Breeze API along with stop loss. I would like to keep a check on PNL in Python itself, and based on the situation, would like to trail the stop loss. Okay, so Raghav, the two things that you have to keep in mind for this, right? Number one, exchange has imposes a order to trade ratio of 50, right? So if you're going to be in the position for, let's say, from 9:15 or 9:20, 25 all the way till say 3 p.m., you may need to move the stop loss more than 50 times, right? More than 50 times, especially if your stop loss is too tight. So, so then you're going to end up hitting the order to trade ratio. You don't want to have to do that, right? You don't want to hit the order trade ratio. That may stop you, the exchange may stop you from trading. So therefore, then you will have to have a strategy of splitting your entire time, the time in trade into 50 buckets time wise. And every time the bucket ends, then you update your stop loss at the exchange, and then next time the bucket ends, then you update. So and in that bucket, if your stop loss is hit, then your trade will exit position. So you will have to keep for the strategy where you keep the stop loss at the exchange, you will have to be mindful of that. Okay. So coming back, we need our expiry date in a particular format. We are struggling with the format. Let's try. All right. Let me wing it. So first we need the date, right? So percentage D be the date, right? Okay. And now I need the month. So percentage month, no. Right. And now I need the year in full. Oh wait. Let's go to Google Earth for this. Python date shift time, and here let's skip straight to this with the references. I mean, guys, nobody expects everyone to remember the entire reference, right? Python reference. So we're looking for a 3 number percentage B. Now, why would they call it B? I have no idea, but okay, gets the job done. So that's percentage D hyphen percentage B hyphen percentage capital Y. Why is it? Does this get the job done? All right, so we're home. All right, so this should get us the call chain. So list call chain is equal to app get option chain data. All right. Without flooding our terminal, let's try to see how many with the length. Oh wait, so it must have returned success code also, right? So if it returned success code, then we need the list within the success. Right, because right now let's look at the length of our option chain. $145. So we have received 145 contracts. Just to make sure that these are actually contracts, let's just look at one element. Guys, also let me know. I mean, I'm doing some live programming. If you guys don't like this format, if you want a walkthrough of ready-made code, if this is getting boring or something, let me know. I'll change the format here and now. I mean, I actually have the format ready. Shinu Babu says, sir, any technical support to build strategy? Shinu Babu, we do give support, right? So the reason why we started this webinar series of live coding or coding a strategy is because we said, a lot of you wanted to understand, to learn coding alongside doing strategy. So that's the whole reason why we are doing this. So Shinu, all the ideas that you guys have given in chat are all great. We will do a webinar for each of them, and we will put the sample code in GitHub. Right? Thanks, Srinivas. If live coding is your thing, then that's what we're doing. Cool. So yeah, so indeed we did get a list of dictionaries, and each dictionary is verified to be a contract. Now let's do the same thing for put chain, right? We want to do them side by side. So now all we have to do is change the variable name, list put chain, CNX ban, NFO, call, chain list change call to put, same expiry date, same product type. Let's run this. Done. All right, let's see the list length of our put option chain. 145, so it should be fairly symmetrical. Let's see if the first element is indeed a put contract. Product type option, CNX ban. Where is a put? Yep, here it is. The right is put. So we have a put option chain. All right. So now we want to do a little bit of cleanup, right? So first of all, not all options would be traded, right? So like, for example, in this very one, this is the very first option, right? With the strike price of 27,500. Pretty sure this is not being traded. And how you know from looking at the option chain is because the LTT stands for last traded time. So the last traded time is indeed zero, is indeed blank. So therefore we know. Johnny Expert says, tough to comprehend this coding. Can you keep it simple first by walking through a ready-made strategy? Johnny, we could go through a ready-made strategy. Only thing is that, then it'll become even harder. Here, one of the benefits that I see to live coding is that, in live coding, I may face the same kind of problems you face, may see some of the same bugs, how to solve it, how to look up things, right? What is shortcut to execute selection VS Code? Oh, cool. That's shift enter, right? So I do, oops. This is one of the reasons I love VS Code, right? So in VS Code, you can just select shift enter, right? That's it. You're done. Shift enter. You're done. Oops. I just flooded my screen. Anyway. So now that we know we have two option chains, we do know that many of these strikes will not be traded. Let's weed out all the untraded strikes, and now how do we know that the clue that a strike is untraded is that its last traded time, LTT, is 0. Okay, so now we'll populate the same variable. We won't create unnecessarily, we won't create new variables. Now, another thing I absolutely love about Python is list comprehensions. And I'm gonna, I routinely overdose on list comprehensions, right? So bear with me. Let's do a list comprehension where we pick out all the items for item in list call chain. If items LTT is not equal to blank. Make sense? I'll just go over this list comprehension once, right? For anybody who's new to Python or new to list comprehensions. So a list comprehension is basically a loop. It's a one-line loop, and I actually like it. It's like a one-line thing, and it forces you to think a bit, right? So I'm gonna make so list comprehension basically says make a list of all items out of the entire world of items found in list call chain. So in this in this option chain, the call option chain, if the items LTT is not equal to blank. Similarly, I mean, we could have made a list comprehension of all the LTTs that are blank, right? We could have said, let's just do this quickly. Okay, let's look at all the strikes. For all lists where LTT is 0, right? Now this little line of list, this little list comprehension should give us a list of strikes. See, all these strikes have LTT that is blank. All of these, okay. So that basically means these strikes are not being traded in the market, or somehow they were not traded for some reason or another. We'll write the opposite risk comprehension, right? Let's look at all the strikes that are traded out of 145 strikes. These are all traded strikes. Okay. Now quickly we'll instead of just taking the strikes, we'll take the entire contract and we'll take it in a chain, right? Now let's do the same thing. Quickly just do the same thing for put options. So from list put chain, let's create the same list put chain but without LTT0. Now let's take a look at what this is. How many there are? Len, right? 77 and 80. So out of 145 call options and 145 put options, we find that only 77 calls are being traded and 80 puts are being traded, right? So now another thing. Now since we want a symmetrical option chain, right? We want put and call symmetrical. We know that there's no use of having a put option that doesn't have a corresponding call option. And looking at this, it looks like it should be 3 of them. But let's use the magic of Python to figure out what not to trade, right? Now this is all setting the stage, guys. Bear with me while we're just doing a cleanup of the option chain so far. We're going to do the automatic strike selection after we have cleaned up, right? So one quick way of finding overlaps is sets. Now, if you guys remember, school level maths, हम लोगों ने उसमें याद एक चीज सीखी थी. We learned about sets. There's a set of elements A and there's a set of elements B. What is the overlap? What is the non-overlap? Union, I think it was called, right? The union of sets. So similarly, Python carried over that entire, idea of sets. So now we can turn our list into sets. What do we want? Do we want the set of the entire the entire option chain? No, we just want a set of strikes, and we want to compare the strikes and move on with it, right? So let me just make it a list of call strikes. Call strikes is equal to, again, list comprehension. Love it. Strike price. You've already seen this, right? How to filter out for item in list call chain. Okay. And we'll make in the same way, we'll make one for put, so that we can get a list of all put strikes that are being traded, right? So this, all right. Now let's turn this into a set, right? Set list all strikes. Now here's the magic part, right? Python has this built-in function for sets, which does what is it? Symmetric difference, right? So symmetric difference will show you strikes that on both sides, in both chains that are not there in the other one. And for this, we will pick list put strikes. All right. So earlier we were seeing the difference is only 3, right? ये देखने से लग रहा था कि इसमें 77 strikes हैं, इसमें 80 strikes हैं. So definitely there will be 3 contracts which are there in the put chain which are not there. But on doing this, on doing symmetric difference, we find out there's actually 5. So क्या होगा मतलब कि there are some strikes which are there in call chain which are not there in put chain. And here we find their strikes. So now we know this is the strike. How can we do this? How to go forward? So let's just make a list of difference is equal to this set. But instead of using a set, let's make it a list. Right? So this should give us a list of different these 5 contracts which are symmetrically not present. Right? So you see this, the same set is now a list. Can we have trading stop loss like 1 click by OI Pulse? Well, thanks for the suggestion. Jitendra, we will look into it, right? So you, Jitendra, just to be sure, you can reply on chat. What you're talking about is a watch list feature, right? On the trading screen or somewhere else, or maybe on flash trade, because on flash trade we are thinking of putting a trading stop loss, to help you, have a better strike rate on flash trade. So Jitendra, put it on chat. Where do you want to see that trading stop loss, and we'll work on it, right? All right, so coming back to this, now we know list diff, we know the strikes that we don't want, right? So let's just go around, use the same list comprehension again. I love list comprehensions. Let's do it with this comprehension. So in call chain, item for item in list call chain, if item strike price not in, I mean, it doesn't get simpler than that. Python key, as far as programming keywords go, not in list diff. It's as simple as that. अगर उस आइटम का स्ट्राइक प्राइस इस लिस्ट डिफ में नहीं है तो उसको नए लिस्ट कॉल ऑप्शन चेन में लो. And we literally just copy paste the entire thing into put also, because put में भी हमको वो नहीं चाहिए, हमको strikes नहीं चाहिए. In both call and put chains, we don't want those strike prices. Done. Okay. Simple as that. Again, let's look at how many elements we are left with. ये तो किया ही नहीं हमने, execute किया क्या? हाँ कर दिया. 76. All right, cool. So now we have perfectly symmetrical option chains. एक साइड पे एक ऑप्शन चेन में कॉल्स है, एक ऑप्शन चेन में पुट्स है, बट दे परफेक्टली सिमेट्रिकल. अभी हम आराम से दोनों पे एक साथ ऑपरेशंस कर सकते हैं. वी कैन कंडक्ट ऑपरेशंस ऑन बोथ ऑफ देम विदाउट वरिंग कि भाई एक में होगा एक में नहीं होगा. राइट. सो नाउ ओके, now begins the real automated strike selection. Now the first thing that we will need, right? The first thing we will need for strike selection is knowing where the spot is. Where is the spot? So based on the spot, then we will determine where the what the ATM is and what the OTM, ITM, etc. are, right? So wait, etc. तो कुछ बचा नहीं, but anyway. But taking spot के लिए क्या करना होगा? So first for spot, I mean, and this is the way I like to do things. You may like to work with the index, but I prefer working with the futures contract. Right? I prefer working the futures contract. So let's say, hey app, Breeze app, get code for stock code is CNX ban. Get me the exchange code is of course NFO. Until BSE comes up with good options. Product type is futures. I want the future, and there is no right, there is no strike price, there is an expiry date, right? So we have already picked out our expiry date. We will copy it from there. After stop is कौन लिखेगा उसको? Okay, this should be enough. CNX ban from NSE future options exchange type future and expiry date should be enough. All right, there we go. Let's take it into a variable. This variable of oh wait, so we want only the success part, right? We want only the success key value pair. Let's take it into a variable since it's going to be oh wait, success के अंदर भी list है. So उस list का क्या करना है? Why do we need a list, right? So let's take that. So dict future, it's an entire code, right? So let's do this way. Cool. So now we have a dictionary containing this. So now we have what will be the LTP? LTP will be this dict with the key of LTP. Here we go. So now using this, so we have already written a function, right? Remember, we already have written the n highest function. And look, I mean, this is the best practice of putting, doc strings there. We'll see, अपना ही लिखा हुआ फंक्शन कभी कभी अपने को भूल जाता है. But because we use doc strings, now see you will get nice help here. So int strikes away. How many strikes away do we want? Usually, let's start with ATM, right? Let's start with ATM. We want ATM missing. What is our spot? Well, spot is a floating number which we got from Dick Fute quote, which is LTP. Okay, this is our spot. Then what is the list of strikes? Let's go first look at our call chain. Okay, let's start with the call chain. Oops. Oh wait, it's the list strikes चाहिए ना? So list strikes did we did a list call chain, but we didn't purify our so we didn't refine our call strikes. So let's refine the call strikes again based on what we have left. All right. Let's call strikes. And let's see what this gives us. All right. So इसने बोला कि see what was our LTP? Our LTP was 41,176. So 41,176 is is our spot somewhere here. What is the strike right below the spot? The strike right below the spot obviously should be 41,100. What did this number? What did this give us? 41,100. Now again, ये comments में लिखा हुआ है. If you read this blue comment, that's precisely. So why am I taking strike as one below the? Why am I taking strike as 1 point below the spot? Why? Because that is how NSE defines ATM when they are doing their VIX calculation. No other reason, just because VIX ऐसे calculate होता है निफ्टी का NSE का. So therefore, I assume कि भाई बाकी जगह भी we should use ATM. We should follow the same convention for ATM, right? So now this is your automated strike selection. That's it. This is what you wanted. Make sense? So now that you know the strike, you can pick that particular contract from the option chain, and that's it. That's what you want to trade in. The flexibility that this function gives you. Now, using this function, you can take 10 strikes away. So your spot is here. Your ATM is right below the spot. And you want 10 strikes away, right? So you make it int strikes away is equal to 10. Pass it this function and 42,100, right? 10 की मतलब 41,100 आपका ATM strike है. 10 if you move in multiples of 100, 10 strikes away is 1,000 away. So that's what it is, 40,100. If you wanted 9 strikes away, well, same difference. That's it. So this is automated strike selection based on count of strikes away, above and below. Let's do below. This example, this function can handle below also. So if you wanted 5 strikes below ATM, right? That's it. 5 strikes below ATM is 40,600. So this function can do both above or below the ATM and highest. All right. So if you guys have any doubts so far, you can put it in chat. Otherwise, let's move on to strike selection by Greeks. Right. That's what we're going to cover. We're going to cover Greeks. We're waiting delta for that matter. And then based on premium, I think premium is a trivial case. We can move on to question and answer and not have to worry too much about premium. Premium, you guys can do yourselves. Homework, or we'll do based on Greeks. All right. So there's this really cool library called Mibian. Mibian may not be the fastest library for Greek calculation. It may not be a wildly popular library, but it is really easy to use. So we're going to use Mibian in the interest of sticking to our strike selection agenda. Maybe one day we will come to our agenda of having a fast Greek and IV calculation. that day we'll deal with more complex libraries which are more optimized and vectorized and so on. So yeah, so today we're going to use Mibian. Let's import Mibian. Mibian is a little peculiar, so I would not be doing a full walkthrough. I'll just take like a from the code snippets that I've already prepared for Mibian specifically. I'll walk through the thing itself, but let's do this. So Mibian, it takes first it takes a list input. In the list, you have to specify. So first we're going to calculate the IV, right? IV comes first. पहले IV हो गया, फिर IV के ऊपर then we can calculate all the other Greeks, right? All the other Greeks. But first you have to, from the observed price in the market, you have to figure out what the IV is. So for IV, you need to tell the LTP. Okay. Here, from the future quote, you will take the LTP. Then you will take the strike price of the contract. You will take the floating risk-free rate, which we did not define, but let's do it. FLT risk-free is equal to, now risk-free rate is, you should be very we will see very soon. Very soon we will see the big difference that the very big difference that picking the right risk-free rate makes, right? So in all its naivete, NSE on their own side, they've used a constant risk-free rate of 10% for the last 10 years. That's not really true. You're living in India, and hardcore quants would probably have their own definitions, maybe American risk-free rate or something. But living in India, I assume that you'll take the Indian risk-free rate. What is the Indian risk-free rate? It is the 1 year GSEC rate, right? And if you guys just look at investing.com or you just Google for it, right? 1 year Indian government bond, right? Pay attention a bit here. I mean, the devil does lie in the details here. A lot of other things you can use, you can take shortcuts, but in this, I would not suggest taking any shortcuts when you're working with Black-Scholes. Look here. So here it says 6.95% is the current yield on the 1 year bond. So you may be tempted to take 6.95 straight up, right? You will be tempted, but let's go a little into detail, right? Here, what's the maturity date? Maturity date is 27th June. We're still sitting on what date? We're still sitting in the beginning of April, right? So pura April, pura May, pura June almost. This is 3 months. Out of 12, 1 year composed of 12 months. This is overshooting 12 months by 3 months at least. So the adjusted risk rate here would be far below 6.95, right? But I'll leave this as a separate topic. If you guys, just bolte hain baal ki khal, if you guys really want to dig into that, into interest rate interpolation and yield curve manipulation, we can come back to that some other day. So for today, we'll just note that this is not, 10 is definitely not right. 6.95 is closer, but it's just warmer. It's not hot, right? Hot will be, so let's take a hot guess ourselves. Let's assume that it's 0.06. Okay, we won't do it too much, but it will be somewhere around 6% only, maybe a little lower. And we will see why this is important. Don't worry, we will come to why this is important in a very short time. Okay. So now we are calculating IV as a function of future LTP, the strike price, the floating reference rate, the floating risk-free rate, and how many days to expiry there are. Well, again, we didn't do this, but expiry from what? Expiry, so today minus expiry basically. We've already imported date time, so we don't need to worry about that. So date time dot date expiry date. So well, why repeat? Or why Let's take this. Right. So minus date time dot date time dot today. What's the date time today? Let's just make sure the notation. Oh, this is a full date time. And this is okay. Let's see if this computes. Yes, it does. And let's put all this in like this and take the days. Should work. Int is not callable. But this didn't give me ints, it gave me a date time. It gave me a time delta. Time delta means days nikalna hai na? Okay. Okay, so it's an object, not a function. My bad. Yep, 19 days. So you've got 19 days to expiry. Now that entire thing will make sense. Right? So now we have calculated the IV. Right? Oh, and as a function of the item LTP, which is our call option LTP. Not implied volatility. So implied volatility is a part of the object. And now that we know the IV, now we can calculate the entire. Now we can calculate any Greek we want. Yep, we're good. And instead of making like an entire new object or an entire new chain just for this, we'll insert IV and delta back into our list call option chain as if we always had it, right? So we just keep augmenting our call, the option chain object itself. So let's do this. This will take a little while. So you can sit back, have some water. Have some more water. Hope this code will be available in GitHub. Yep, definitely it will be. I'll put it there as soon as it's done. Yep, now it's finished thing. So let's see. What I wanted to have was the IV and delta in the option chain as if it was always there. So let's just take a look. Yep, that's where we see it. We see delta. Ooh, it has a delta 1. Okay. Let's see. Just double check the last. Yep, it has a delta of 0.006. So we see delta and IV both are present now in the option chain. Let's quickly do the same, repeat the exercise for our put option chain, and then we will see why we were first making that huge fuss about the interest rate. We'll basically put the IV and delta side by side, and I'll remind you of a basic principle that we had. So here put price. So for item in this put option chain, get this, and implied volatility, and here we want put delta. Everything else remains the same. For some more water. Right, this was fast. Bacha seekh raha hai. Now let's just inspect the elements. Let's see if everything is fine. Let's see the last element of the put option chain. Yes, we see a almost minus 1 delta and IV of 24.71. Let's quickly check the first element. Yep, we have IV of 36 and delta of minus 0.03. Now let's come back to the interest rate. Why were we fussy about the interest rate? We were fussing about the interest rate because of a very basic principle in options. That is very basic principle that says for a particular strike, you have a call and a put. The IV should be the same. This is an inviolable principle. Okay, let's take a look at Nifty option chain. Okay, sorry, NSE's Nifty option chain. Right? You see what I'm talking about here? Let's go here. What is IV calculating again? So IV for 17,650. Look at the IV for 17,650. Call का IV क्या है 2.07. Put का IV क्या है 5.44. Come on. How can you have such a huge difference? I mean, more than double. इतना difference होना ही नहीं चाहिए. I mean, it's a very simple principle. अभी आप change करेंगे. We'll do it once right now. We will increase and decrease, and you will see the call and put IVs coming together and moving away. As you move towards the right interest rate, the difference between your IVs will start shrinking. Now, IV calculation itself is a very cumbersome process, so therefore you probably don't want to optimize your goal seek your interest rate by changing your IVs, or rather goal seek your IV by changing the interest rate. But ठीक है. Let's just do it once. Okay, एक बार करते हैं. So let's say instead I use 5.8%. Okay, everything else I changed nothing else. I just changed my interest. I just brought down my risk rate by 0.2%. It'll take a little time. In the meanwhile, let's start separating the IVs. So list call IV is equal to item IV or item in list call chain. Okay. And the same thing we'll do for puts. And why don't we do some clever stuff with this? We'll just zip it, right? Okay. Zip. Oh. Just see the zip as a list. Notice this. See. Take a look. Let's see the first 10 elements. Is this how you see the first 10 elements, or was that pandas? Yeah, first 10 elements. Right? Note. Wait, why is list call IV also? So the list call IV seems very strange. None values are real. No, must be some badly traded ones. Let's look at the list zip again. Maybe in the middle. See what I was looking at, or looking for rather, are values that are close. So here we see the values that are rather close. 12.5 and 12.88. 12.26, 12.99, and as you move ahead, the values will keep diverging. Here you have 11.9, you have 12.72, but it's still relatively. I mean, and look at the divergence here, 45.9, 55.55. So it will keep diverging. Of course, I don't know where these extreme divergences are coming from. You have to look into that. But ideally, what you want is IVs which are very close to each other, right? You remember, right? The NSE में अभी देखा था हम लोगों ने NSE में there were huge differences, double, triple, or whatever. But here, this is roughly, we're very close to the principle of having IVs that are the same. All right. So again, not to get too pedantic about this, but yeah, the idea is to have IVs and this. So again, we come back to our strike selection based on delta. So now we have deltas also, right? What we normally want with delta. Deltas will usually be call delta, put delta would usually be in the opposite direction. Why? Simply because, um, you know, they're basically non-linear in the opposite ways, right? The value of a call option increases as the price increases and it is in the money, right? And the value of a put option increases as the spot moves down, right? So therefore, the deltas can be expected to be opposite, and that's where we get delta hedging, right? So we now what we need is the right hedge. We need, let's say, we need the strike at which deltas are almost zero. Okay, let's make that. So let's make a list of call deltas is equal to item delta for item in list call chain, and we'll make the same, do something with puts. Okay, so now we have a list of call deltas and we have a list of put deltas. Now let's make it again this comprehension and make a list of some deltas. So we will have a call delta in zip, right? So we need to iterate over both lists at the same time, and zip is the way to do it. So list of call deltas, comma, list of put deltas. Right. So now we have a list of sum of deltas, right? And now we see in the extremes you will have minus 9, minus 0.9 delta, sorry, plus 0.9 delta. Our list starts from the very positive and goes to the very negative of minus 9.8. In the middle, we will have our near zeros, right? So here we see ये रहा अपना near zero. You can expect that this will be somewhere around the ATM. Somewhere around the ATM, you will have this thing. So now since we've already imported the bisect library, let's just use the bisect library directly. Let's not worry too much about making a fancy function. Although if that function was adapted, it could have been used here also. So we bisect left. What do we bisect? Let's not worry about this. What do we bisect? We bisect list of sum delta based on not floating spot 0. And we don't move any strikes away here or there. Now let's look at this in why would it do that? 9936. Let's take a look into the bisect function for a moment. But in the list, maybe bisect would be the right thing to do, not bisect left or right. Bisect is also giving something. So yeah, I mean, you get the point though, right? I mean, you have a list of some deltas, you find the zero, you find the best place, maybe bisect library is not the best way to do that. but you find the value that is in, as close to zero as you want it to be. So I would assume it will be somewhere over here, right? So maybe we can list find this thing. Index returns. So index is the given element. Okay. So we can try. Let's try to use it. Maybe if Python gods are happy at us. So we'll list some. And I know this is not complete automation, but it's as close as we can get in this session. $48. All right, not bad. So 48 is the index that we're looking at. Index of 80 of near zero delta. Right? And if we just had if we just coded a way of this thing, then we could have easily found the thing. So now list call chain ka 48th element, or rather the index zero delta element. This is the selected strike for call. Repeat the same thing for put, and you have the put ka or rather because it is symmetrical. What we are doing is symmetrical. We have taken care from the very beginning, right? So this would be your 41,100 strike ka wo, because again, remember 40,100, that's the ATM. It's but natural that at the ATM you have got deltas that are almost exactly squaring each other off. All right. So here we will end today's session on deltas. So we learned two different ways of automated strike selection. We learned automated strike selection based on absolute count away from ATM. We learned that by using this simple function, that's it, we're done. Then we went on a greater, not a wild goose chase, because we actually got our wild goose at the end. But yeah, based on Greeks. And the Greek that we chose was delta. You could choose any Greek that suits your trading style, and you can do that. Okay. Another question, Priyam is asking, have you deleted files from GitHub? Where is the code from last 2 weeks? So the code is on GitHub only. Python examples. I think there's been just some rearrangement of code. So option plus code is here on how to place an option plus order. Why delete Salil's files? Salil is the one who maintains this, by the way. I don't do too much interference in this, at least as far as webinar is concerned. So I didn't delete Salil's files. Some of my code has been moved to this, in getting last weekday, So this is something I wrote to help people download historical data, because when you're downloading multiple expiries data, you need to know the last weekday. So I did a small function for that. But yeah, I didn't delete Salil's files. I'll ask Salil, whether he has deleted any files, and he'll put it back. Yeah, we'll take that as a request, Priya. Rearrangement has lost some files. I hope Salil gets well soon. He seems to have quite a fan base here. So, as soon as he's back, I'll ask him to, reinstate any files that he may have deleted. Yeah, regards to you, Priyam too. Anyone else has any questions? Please put them in chat. Any great session. Glad you liked it, Raghavendra. And yeah, we will come back to you with sample code for trailing stop loss, right? Shanos, what is the procedure for user to get access to ICICIdirect? Shanos, there's no procedure. There is no procedure. If you have a ICICIdirect account, That's it. Let me log in. Let me show you. See, I've already been logged out, right? So you see this URL? I'll here. Yeah, Shanos. This is the URL, https://api.icicidirect.com/api user/home. You just go to the top, you put in your normal ICICI Direct credentials, username and PIN, click login, it'll ask you for .p, you submit the .p, and that's it, you're home. You can get started. Create an app here. On register an app, you can view all the apps that you create here on view apps. You can see the Breeze documentation, and you can go to the SDKs. Right? Install the SDK and you can get started. You're welcome, Raghav. Nice to have you here. I hope it didn't get too technical and scare people off. It looks like we went from like 45 people to 23. So yeah, either some of you have fallen asleep or you got bored and left. Yeah. Yeah. You're welcome, Shanos. So I think we can call it a day. I think we've already overshot our time by 8 minutes now. All right. Thanks, everyone.
Subscribe to our YouTube channel and click on the bell icon to never miss an update from ICICI Direct.